Hi, in this lecture, we're going to talk a little bit about skeletal muscle performance. And we're not going into a lot of exercise science and exercise physiology, but I just want to give you an overview about muscle contractions and how we can improve our aerobic and anaerobic performance. So first, there's different ways muscles can contract. There's two general ways that they contract. They do isotonic contractions or they do isometric contractions. So an isotonic contraction is when the muscle actually shortens or lengthens while developing tension. So we do these all the time. When we, in this example, lifting a biceps, using the biceps brachii to do an arm curl, when you do the arm curl and you bring the weight up, right, as the muscle shortens, that's considered concentric work. But then when you let it go, you don't just drop it, right? When you lift weights, you're very smooth and you control the weight as you lift and bring it down. So when we bring it back down, the muscle's developing tension, but the muscle's lengthening. So that's considered an eccentric muscle contraction. So when we look at our isotonics have a concentric and eccentric. Now, sometimes concentrics are called positives, and you're going basically against gravity, whereas eccentric are sometimes called negatives because you're controlling the weight. You're kind of like the myosin is kind of like letting the actin out, like kind of like one link at a time. It's under control. The isometric, on the other hand, when we see these, this is when the muscle generates tension, but it doesn't change its length. So again, concentric, shortening, eccentric, lengthening. And, another example of eccentric is if you've ever walked down a steep hill. As you're walking down a steep hill, all the muscles on you, like your quadriceps, front of your shin, front of your thighs, those muscles are contracting eccentrically to basically prevent you from, like that hole when you start running down like a little kid, and you lose control. So, and the eccentric work does cause more muscle damage, which I'll get to shortly. So here's a quick comparison. Isotonic muscle either shortens, concentric, or lengthens, eccentric, while developing tension. So you're using the muscle. Isometric, the muscle generates tension, but it doesn't really change its length. It's in one position. So again, you can see when you're doing your biceps brachii arm curl, if you were just holding the curl, that's isometric. So all three of these help make your muscles stronger. Physical therapy situations tend to use more isometric a little more because you can really control the angle that you're working the muscle. And you wouldn't ever want to just do isometric because, if you were doing isometric here, then your biceps gets really strong here. But who just needs it there, right? So that's why we work the full range of motion on our muscles. And so we know that when we develop tension and when we lift and exercise, that we're causing little cellular traumas. We cause these like cell damage and micro traumas. And when you damage the muscle, it responds by putting more protein in it. And research is actually showing that a lot of those muscle cells actually replicate. So your muscles get bigger. So they have to, no pain, no gain to some extent. So when you work out and you put tension and you put force on your muscles, the tiny little micro traumas cause a little inflammation. Makes you sore later. We'll talk about that in the clinical piece. But we also know that the negatives, the eccentric, cause more muscle damage. So some people just do eccentric work. So maybe if you're doing a bench press, okay, so when you're doing a bench press, when you push up, that's the positive. Bringing the weight down is the eccentric or the negative. But there's some people just do that because it causes more muscle damage, and the idea is you might get stronger, but really both of them are essential. And if you're trying to get stronger, you really want to work your muscles through the full range of motion. But that's what is going to cause muscles respond to the tension, to the damage by getting bigger and stronger, more protein, replicating cells. Now let's look at some things that happen with conditioning. So there's a couple things we look at. There's power and there's endurance when you're looking at skeletal muscle performance. So power is like how fast, right? Quickness, how fast you can produce the force. Endurance is how long you can sustain the activity. And so power and endurance, we know they're going to depend on muscle fibers. We know our power fibers are going to be more of our type 2s, especially the 2X. We know the endurance are going to be our type 1s, but we can develop these, as we talked earlier, through conditioning and exercise. So maybe you want to work more on your aerobic training, your endurance training. Well, we know for one thing, they'll help your type 1 fibers work better, right? We also know they could convert a 2X to a 2A. They could make your type 2 power total power, work more, give it a little aerobic ability. We know when we exercise, it helps our heart. Our heart actually gets a little bigger and thicker, and that increases what's called the stroke volume. The stroke volume is every time your heart beats, it contracts and it pushes blood out. The stroke volume is the amount of blood that leaves. So as your heart gets stronger and stronger, it pumps more blood out. And then what that does is allows you to have a lower heart rate. So athletes typically have a lower heart rate. We know that we increase blood vessels to our muscles. We increase the mitochondria and myoglobin. So that's going to help those type 1s, and that's what's going to try to convert the 2X's more like a 2A. We know that, as I mentioned, muscle fibers get bigger. So they start to enlarge. You put more muscle protein, more myosin and actin in there. Having more mitochondria allows you to use oxygen better. So maybe you decide to start running or jogging, in my case, slow jogging. So when you go, maybe you make it, I don't know, a quarter mile, and you alternate walk and jog, walk and jog, walk and jog. And then you'll notice after a week and after 2 weeks that you're jogging longer than you have to walk, because your mitochondria replicate, more myoglobin, so your muscles are better at using oxygen, which means you can jog longer. We know that we clean out our arteries. I'm not sure why I have this on here twice. So it helps lower your blood pressure. It increases the good protein, the good lipoprotein. You want to heard of cholesterol. HDL is the good one. It helps clean out your arteries. We know it does a lot of mental changes. There's a lot of research showing that exercise helps memory. So, take a walk, exercise, listen. I don't know if you really want to listen to lectures while you walk, but it does help with memory and learning. And it releases some really important neurotransmitters. Serotonin helps you feel good, helps you feel happy. You get a dopamine spike from exercise, and your endorphins are your body's natural painkillers. They cause the natural high. We also know it helps our immune system work better, and people who exercise live longer. So this is all aerobic exercise. Now, if we're working on our power, remember that, power is going to be working at a higher intensity. And by the way, I just want to come back really quick and mention that, remember that if you are working aerobically, we can check your heart rate. So you're pretty much below 70% of your max heart rate. So a lot of us have these fancy watches that tell us our heart rate, but remember, as we increase the exercise intensity, we switch over and work more anaerobically. And you have hyperplasia and, I should say, hypertrophy here. So technically, hypertrophy is when the muscle gets bigger, and hyperplasia is when they increase in number. And so we know that typically what happens is we increase both the number and the amount of protein in our muscles. So they're going to get bigger and be more numerous. If you don't exercise, then what we know what happens is the muscles actually atrophy. So again, make sure you understand hypertrophy, increase in size, hyperplasia, increase in number. I actually said that wrong at the beginning of this slide. Okay, anaerobic. So we want to improve power, right? Speed. There's training that we do in order to do this. So our anaerobic endurance is how long we can do glycolysis. And, there's only so long we can do it because we're going to make all that lactate and lactic acid. So you're basically increasing when you turn over into that obla, or pushing back when you convert over to working anaerobically, because once you start making lactate, you can only go so long. So anaerobically, we're limited, one, by our energy stores, right? We only have ATP and CP, 10 to 20 seconds at the most. Now, some people take creatine phosphate. Honestly, the little bit I've seen about it is, very, very mixed. But at the most, if it gets absorbed through your stomach and your small intestine, you might get like 1 or 2 seconds extra. So, that might give you one more rep at the gym. I don't think it matters for most of us average people. Also, our ability to store glycogen, because remember that if we don't have glycogen, you basically hit the wall. If you ever tried to do something really intense and you haven't been eating properly, when you run out of glycogen, you have no glucose, and anaerobic can only use glucose for energy. So you're literally done, right? You can't go on anymore. And then we also try to build up our lactic acid tolerance. So we try to be able to tolerate it better. So, power, speed, strength training, it's specificity of training. So you have to do the explosive training. You have to do the intervals. You have to do the sprints. You have to do the jumps. You have to run the steps. You have to lift the weights, right? It is tough, but you're actually developing these anaerobic systems, which makes you faster and stronger and more powerful. So when we're looking at muscles, again, just understand that when we exercise both resistance training, which is weight training, and endurance training or aerobic training, both are going to cause changes in our muscles. In fact, let me go back here for a minute. The resistance training also increases all of those glycolytic enzymes. So the process of glycolysis you learned in Bio 119, but you have a lot of enzymes that you need for all these reactions to occur, and your body gets better. You make more enzymes and it makes you more efficient at it, which is how it helps make you faster and stronger. Notice that whether we do resistance or endurance, that our muscles get bigger, but they tend to get bigger from resistance training. So strength training, resistance training, it is important to have that in your daily routine. It can be body weight training, push-ups, pull-ups, those are all really good. But what happens is you get a little bit more of the myofibrils, and the muscles tend to get a little bigger from resistance training. And we already said if you don't use your muscles, right, they're going to shrink and become weaker. Now, there's a couple things that have been kind of interesting in the last few years as far as training goes. And one of them is when we look at hypoxic training. So there's masks you can buy. There's ways to do hypoxic training. It looks like, I've seen that a lot of the times it's been done with swimmers, holding your breath. And there's a lot of mixed research on hypoxic training. However, there have been some studies that have shown some benefits from the hypoxic. So you're basically decreasing the oxygen available. So one, it makes you work more anaerobically. So it does help develop those glycolytic enzymes and boost those pathways. But when you're hypoxic, your body releases something called EPO. You may or may not have heard of this. So EPO is a hormone. And what it does is it increases your production of your red blood cells. And red blood cells are critical for oxygen, for aerobic work. So it has shown to possibly have some benefits regarding that. This is a study that I found, or this is just an overview. Actually, this is the overview first of some things for hypoxia. You're not memorizing all of this at all, okay? This is more almost like an FYI, but I just want you to know there's two things that they do now to try to stimulate this. Aerobic training, and they do this for strength training. They do blood flow restriction, which I'll talk about in a minute. But hypoxia, there's like intermittent hypoxia. So the idea is that you sprint and you're hypoxic. And the idea is you're putting more stress on your body by making it work, in a low oxygen environment. And so one study showed, you can see hypoxic training group here. And so your VO2 max is your aerobic ability, basically, how fit you are. You can see your anaerobic power as well. And then they had them do some weight training and they looked at hormone release. And so, there were some changes on the anaerobic power. Here's the normal and here's the hypoxic. So notice the hypoxic went up in that. They also, if you look at their weights, right, they got stronger. And so it seems to be coming down to a couple hormones. So growth hormone, remember, triggers bone and muscle growth. So this group did have a higher, this is the hypoxic group, surge in growth hormone and insulin-like growth factor. So it's a training that some people do. It does seem to have some benefits, but I've also found studies that say it does not. So, basically it's specificity of training. So if you're in a sporting event, I don't think you're ever going to have one of those masks on. So it's probably better just to do the sprints. Now, blood flow restriction training is basically you put a resistance band on your arm or your leg, and don't mess with this on your own because you're basically decreasing blood flow to the muscle. And I don't know how they figured this out, but what they found is that the blood flow restriction training triggers the release of growth hormone and this other growth factor. And so one thing that they found is that normally in order to get your testosterone and your growth hormone released, you got to really trigger those type 2X. So you have to work at a pretty high intensity when you're lifting weights. But what happens with the band is you put the band on and you lift much lower weights. So the weight that you're lifting is much lighter, but you actually get a stronger effect. So you get a high, look at this is high intensity exercise. Here's your blood flow. So notice it was significantly higher than just weightlifting alone. So if you're weight training, you're probably getting up close to a 1 rep max when you're lifting because you're trying to stimulate those 2X's. But the blood flow training allows you to lift less weight and get, it looks like so far, the same benefit. So they do this a lot in physical therapy. If you're recovering, right, you can't lift the heavy weight because you're trying to, rehab a joint or a bone. So they'll do this a lot to try to maintain your muscle mass and your muscle strength as you're going through the rehab. So then also muscle fatigue. So we talked about wave summation and tetany, and basically once we're at our max contractions, we can only hold it for so long, and then muscle fatigue occurs. And notice that the force rapidly falls. In fact, sometimes you'll drop the weight, which is why you have a spotter. And so we know there's several causes of muscle fatigue. One reason is that you basically start to run out of calcium. And so if you don't have enough calcium, you're not eating calcium enough, then you might not be able to maintain the strength. You also can run out of ions, sodium and potassium, so and also dehydration. So you always want to make sure that you're eating well, that you're hydrated. Eat a banana a day to get all that potassium. There's a lot of phosphate. So remember, when ATP is used up for energy, it produces ADP and this phosphate. Those phosphates accumulate in the muscle, and they cause muscle weakness. So that's one of the leading causes of fatigue. And there's nothing you can really do about that because you can only go so long, right? Muscles can only contract so long. When you're working anaerobically, you start to make more lactate. That makes your muscles burn, changes the acidity, and that burning might make you stop the activity. Glycogen, you run out of glycogen, right? Remember, glycogen is the storage form of glucose. So if you run out of nutrients, you can't make energy. And then environmental factors, things that could make you dehydrate faster, right? Extreme heat could do it as well. So these are just some of the causes of muscle fatigue. But overall, we do fatigue. And when you're lifting weights, you actually try to work to fatigue because that lets you know that you've worked your muscles basically hard enough. And then we have muscle tone. So muscle tone, every muscle is partially contracted at rest. They have to contract all the time to maintain our body position, right? Like holding my head up, holding your posture. Those muscles never get a break. Otherwise, we'd be all floppy in the corner. So they're constantly contracting just to maintain body position. And so muscle tone is what gives you muscle definition. So obviously this person has very nice muscle tone. You can see the muscles. So it's a combination of low body fat, so you can see the muscles, and tone. So they're contracted, and the more they're contracted, the more they bulge. Well, things that increase muscle tone are exercise. So if you lift weights, you have more muscle tone at rest than someone who doesn't lift weights. So you're going to look more buff because you have more muscle tone. And the benefit of that is that when those more muscles are contracted more, you're burning more calories. So you have a higher metabolic rate than someone who does not lift. And by the way, all exercise increases your metabolic rate. If you go for a walk today or a jog or ride a bike, your metabolic rate stays higher for 24 hours later. So it's higher tomorrow because you exercised today. Now, we do know that there could be issues with muscle tone. So if we have too much hypertone, these are different diseases that affect it. Hypertonia, you have more spasms and stiff limbs, where too much muscle tone versus hypo is too little. So the limbs tend to be floppy with low muscle tone. So those are terms you might see with some muscle wasting diseases. And then we just need to talk about the recovery period. So you go out for a walk or a run and you hit a steep hill. When you hit that hill and you start going up the hill, your breathing changes, because when you hit the hill, you are actually like depleted of oxygen momentarily because you're working so hard. And you might notice once you get to the top of the hill that you're breathing even faster. So the recovery period is basically the time that our muscles go back to normal after we increase our exercise session, or after we go through increase our exercise intensity. So it's just the time that we get the oxygen back and that we resume our normal mitochondrial activity. So here's what's going on. So we have a few things happening. We have oxygen debt and we have oxygen deficit. Now here's where we're getting to exercise physiology. So this is just a real quick overview. Basically, let's say that you hit the hill. As you start going up the hill, you're in an oxygen deficit. So when you start the exercise and you transition into the higher intensity, like going uphill, you technically don't have enough oxygen to maintain that activity, so you're in a deficit. Once you get to the top of the hill, now you have an oxygen debt, so you're repaying the oxygen debt, because once you're at the top, you need more oxygen, basically to deal with the fact that you didn't have enough oxygen coming up the hill. So we breathe really, really heavy. So the deficit is what happens at the onset of the activity. It's just a delay, basically, because you're working harder. After you're finished with whether it's a sprint or going uphill, now the oxygen debt happens after the activity. And this is also something called EPOC. And that just means post-exercise oxygen consumption. And so this is what happens after the activity and you're paying back the debt. So what you're doing is you need more oxygen, basically. So you're breathing faster and faster. And you need more oxygen because you just made a bunch of lactic acid coming up that hill. So you got to get rid of that lactate. So the lactic acid is going to be converted. It actually gets converted back to glucose. We're going to need oxygen to restore any ion gradients that changed. You get rid of hydrogen ions. And then you might have a pH change because lactate has, lactic acid. So we're also buffering that pH change. So after the activity, we do breathe faster for a period of time to repay the oxygen and set everything back to how it was at the beginning. Now, the more trained you are, the less time it takes. So you might notice if you do sprints, you're like breathing really heavy for a while, but if someone's more trained, they pay it back a lot faster. So again, you're basically, just a side note, I'm not going to ask you Cori cycle, but what happens is all that lactic acid gets converted back into glucose, basically. So it goes into pyruvic acid and it gets converted into glucose. Now, lactic acid isn't all bad. Your heart uses it. We convert it to glucose. It is not what makes us sore, right? It does not make us sore, 2 days after the activity. Those are those micro traumas that occur. So I just want to mention a little bit about the debt and the post-exercise oxygen consumption. And this is why a lot of times your metabolic rate is higher. We know that when we exercise, our oxygen consumption is higher. And again, it can be higher it's usually about 24 hours later that you actually burn more calories. And we're just going to wrap this one up by just looking at some hormones and how they affect our skeletal muscle. And some of these you saw from bone. So we know that growth hormone comes from the anterior pituitary gland, and it's an anabolic hormone. So anabolic protein synthesis. It's going to make our muscles bigger and stronger. Same with testosterone from the testes. In fact, these are often abused, right? When you hear about anabolic steroids or people abuse growth hormone. And we'll talk about that a little bit when we get to the clinical. The thyroid hormone, thyroxine, is called T4. Remember from bone, it also triggers muscle growth. Now, epinephrine, it's known as adrenaline, but epinephrine comes from the adrenal medulla, and that we know directly goes to muscle, skeletal muscle, to cause increase in muscle contractions and strength. When you exercise, you release some epinephrine to help increase your muscle strength and your muscle contractions. And this can also be released during extreme stress, right, where it's able to activate all of the motor units for these like superhuman strengths. And then cortisol we talked about before as well. That comes what's called the outside of the adrenal gland, the adrenal cortex. And remember, that's different. That's catabolic. So we release cortisol when we exercise because we need to. Cortisol helps us maintain blood glucose levels. So it keeps our blood glucose levels there so our muscles can use it. But if it's elevated or we release it too much, which it's released a lot in stress, it actually can start to work the opposite direction and start breaking down our muscle. And this is called gluconeogenesis. You might recognize that word. That's when we take glycogen, or actually it can be glycogen or glucose because glucose comes from glycogen. And we're trying to form glucose or glycogen, but we form it usually from amino acids. So I always think of it as forming new glucose. So you're forming glucose from amino acids or from fats. In this case, it tends to take the amino acids from your protein and use them to form glucose. So this concludes our lecture on skeletal muscle performance.